Good afternoon, students. So, in this video, we will discuss about identical particles and their applications. So, basically, in this, I want to tell that we will learn some quite basics, not their detailed concepts. Because I know this is not the proper way of teaching physics, because you should know the reason behind every formula or every reason you put, every comment you put. So but in this short, because due to the time constraint and other issues, like to improve problem solving skills, we have to do more problems rather than read it theoretically. But the best I can do this only. I know many will not be happy by this way of teaching, like not explaining detail concepts in very detail. Very means it, if I tell it in very detail, then it will be video will be very lengthy. So our focus is on problem solving. So it will come by doing many problems. So I hope you will understand this. So let's start the video. So first I will talk about identical particles. uh, in classical mechanics, identical particles means you can distinguish between them, but in quantum mechanics, they are truly indistinguishable. Okay. You know, that is very basics. I am going particles with integral spin, mm, that is multiple of h cut 0 1 2 3, such as photons, pions, alpha particles. These particles are called bosons. Particles with half odd integer spin, h cut by 2, 3 h cut by 2. I hope I missed 2 here. So it is 3h cut by 2, 5h cut by 2, 7h cut by 2. They are fermions, such as electrons, positons, protons, and neutrons. These are fermions. Okay. So now particles which you see are only of two types in nature. They are bosons or fermions. Okay. So entire your particle physics lie in these two, bosons or fermions. Okay. So I am not going in particle physics. So I am only telling the basics of this. So particles with integral spin or bosons have symmetric state. Particles with half or integer spin or fermions have antisymmetric states. So so what I mean by symmetric state and what I mean by antisymmetric, I'll tell you in bit later. But fermions obey Fermi direct statistics and bosons to obey Bose-Einstein statistics. So these are the basics. Now here I have shown the what is symmetric wave function and what is antisymmetric state. So symmetric state is, this is 1 by under root 2 psi a1 psi b2 plus psi a2 plus psi b1. So basically if I go in this is the symmetric state function. So when see, basically the particle, if you only put the particle in psi a1 psi b, if you only write this state, if you write only this state, if this is not the correct, because it is in the superposition of 2, it is in the superposition of 2. So you have to write this term also. This is in the superposition. Okay, this can be in any of the two states. That is your A state or your B state. Okay, so here I can define that the particles are given by 1 and 2. Okay, so you can write this. So 1 by under root is the normalization constant. You can think this is the normalization constant, 1 by under root 2, and psi a1 plus psi b2 plus psi a2 plus psi b1. So it is in the superposition of 2. It cannot be in one state, so you have to take if in before after the result in one state, then after you measure, then after in second state, so you have to write both in both the way. So that's why it is plus psi a2 plus psi b1. So that if it in first state, then it is in second state, then b is in second state, and then b is in first state. So similarly, antisymmetric wave function nothing but you have to put minus sign. These obey symmetric obey Bose-Einstein, and antisymmetric obey Fermi Fermi-Dirac statistics. So let's come in Pauli exclusion principle. So in Pauli exclusion principle, electrons can occupy simultaneously the same particle state. So basically I will explain this like say if there are n identical particles, so no two fermions basically fermions have spin half 3/2. So I'm talking of all the fermions. So I'm talking about all the fermions that can occupy, and can occupy the same, no two fermions can occupy the same single particle state at a time. Also, if you take a specific example of electrons, so no two electrons can simultaneously take the same single particle state on the same atom. Like there is a one electron, and there can only one electron occupying a state of quantum numbers, such as we know quantum numbers are n, l, ml, msi. N is your principal quantum number, and l is your azimuthal quantum number, ml is your magnetic orbital quantum number, and s is your spin. So I can write here about quantum numbers n, l, ml, ms, s. So this is principal quantum number. So this is principal. This is orbital. This is your orbital. This is orbital angular momentum. This is your your ml. Like if your L is 2, then ml can take values from -2, -1, 0, 1, 2. So it tells about the orientation. It tells about the orientation. It tells about the orientation. So S is the spin. Similarly, if S is equal to, see, if S is equal to your like you can take it is half. So spin is half, so ms can take values -half or half. So this way you can write this -half to half. So L is -2, -1, 1, 0, 2. So basically ml goes to -L to L. Similarly, therefore ml goes to -L, 0 to L. Okay, so ms also goes to minus your S to plus S. So you can take either the way. Okay, so bosons do not have these restrictions, and filling bosons do not have these restrictions, so you have to keep it in mind. So this is very important, that bosons do not have above restriction. Okay, so now next point, filling is always done with rule 2s plus 1. What is this rule? This is very important rule in which all the sum we will do will based on this formula 2s plus 1. I will tell you when we're doing sum, so you have to remember this. This is very important. I must mention it is very important to this. Okay, so you have to do this in this form. Okay, so this is the basics I have. If anybody do not know, then it can he or she can look it in detail, but these are not only the small things which will require in solving our problems. Okay, so Now let's move to our problems. So we will move to our problems. So the first sum is the minimum energy of a collection of 6 non-interacting electrons of a spin half placed in 1D infinite square well potential of width L. So we have given the infinite square well potential. Infinite, we all know that infinite square well potential is given as, so it is given as 0 to a minus infinity to infinity v equal to 0. So psi is equal to under root 2 upon L sine n pi x by L. So you have to remember this. Okay, and energy level is given by n square pi square h cut square upon 2 ml square. Okay, so this you have to see. Okay, so you have to see this. Now the problem is so how to approach this problem. Okay, so there are 6 non-interacting electrons. So electrons, we know they have a spin half. So when they have a spin half, now I told you about the master formula, that is 2s plus 1. So if there it is 2s plus 1. Okay, so if you apply here 2s plus 1, s is the spin, so spin of electrons is half, so 2 into half plus 1, so it becomes 2. So it becomes 2. So only 2 electrons can occupy one state. What I do mean by state is like n is equal to 1, n is equal to 2, n equal to 3, n equal to 4, and so on. So only 2 electrons. Okay, so only 2 electrons can occupy the state n. Okay, the state n. So now if 2 electrons can occupy the state n, that is n I mean by 1 2 3. So if I do filling, this is n is equal to 1, n is equal to 2, n equal to 3, n equal to 4, or n equal to 5. So only 2 electrons can occupy this. So this becomes, so I can only put at most 2 particles. So what is the state, what is the n is equal to 1 energy level, n is equal to 1 energy level, I will put in this formula. So it will become formula, I can put it with 1. So when I will put it, I'll get pi square h cut square upon 2 ml square. So there are 2 electrons, so I will multiply it by 2. N is equal to 2 means 4 pi square h cut square by 2 ml square into 2. Okay, so now this will become 9 pi square h cut square by 2 ml square into 2. So this will become equation number 2, 3, 4, and when I will add this, so you can see when I will add this, I will get 14 pi square h cut square upon 2 ms square. So you can do this. This is very easy, nothing any rocket science in this. So only one formula, 2s plus 1, you have to check with the spin. So how many electrons can it accommodate with will be done by the master formula 2s plus 1. Okay, 2s plus 1. So only here 2 electrons can accommodate in one state. So we'll get 14 pi square h cut square upon 2 ma square. Okay, now the next is 2 identical non-interacting particles, each of mass m and spin half, are placed in 1D box of length L. In quantum mechanics, the lowest possible value of the total energy of these 2 particles is epsilon naught if instead 4 such particles are introduced into a similar 1D box of length 2L. So think it is good. Yeah, okay. So you have to only tell the total energy of these two particles epsilon naught if instead four such particles are introduced into a similar 1D box of length 2L. So see, simply when you have asked two identical non-interacting particles of mass m and spin half are placed in 1D box of length L. So first, how many two identical particle, what he is trying to say, two identical. So this is our box 0 to L. So only you can put two identical particles, so it will accommodate the n is equal to 1 state. Okay, now in quantum mechanics the lowest possible value of the total energy of these two particles is epsilon naught. So we have given the lowest, that is ground state energy, epsilon naught. If instead four such particles are introduced into a similar 1D box of length 2L, now the width is shifted to L. So width is here L. Now it is shifted to 2L. Now it is shifted to 2L. So first here what I can say, the total energy is epsilon naught. It is given. It is given. Okay. Now so it is given. So what we can do this means 2 into pi square h cut square upon 2ml square is equal to your pi square h cut square ml square. So what is it is epsilon. This is given. This is given in the question. This is given in the question. So now now the width changes to 2L. So now my formula will become, so my formula will become, after changing the length 2L, it will become E is equal to n square pi square h cut square upon 2m 2L square. So what it will become, m square pi square h cut square upon 4 to 8 it will become 8ml square. So now you have to put in this. So new energy state is this. So now it is asking that four such particles are introduced in this. So four particles will be introduced. So it will take value, this is epsilon naught and 4, like you can do this, that is your this will become like En is equal to, so it will become 8ml square. So now E1 is equal to, when I'll put the n is equal here, I have to change the color, n equal to 1. So when you will put n equal to 1, it will become pi square h cut square upon 8ml square. Okay, so my epsilon naught is pi square h cut square upon ml square. So I can change this, pi square h cut square upon ml square is epsilon naught. So I can change this epsilon naught. So I can here are two particles, so you can, two particles are here, so you can do this 2 into pi square h cut square upon 8ml square, and here 4 into pi square h cut square upon 8ml square. Similarly you have to add this. So when I'll add this, I will get 5 pi square h square upon 8ml square, and pi square h cut square ml square we will, I know it is epsilon naught. So this is we have derived, where this is given, so it will become 5 upon 4 epsilon naught. So this is final answer. So this is final answer. So basically you have to understand what it is saying, like first you have to we have to convert this English into your the given mathematics. So here this statement, two identical particles and two identical non-interacting particles in 0 to L box. So what it means to say, it means to say pi square h cut square upon ml square is equal to epsilon naught. This is the main hidden thing which you have to first calculate, and then when you calculate this, then change the width to L to 2L, and the formula will become n square pi square h cut square upon 2m 2L whole square. I have done this in the first video, you can look this. I have explained in detail that how width we can change. Okay, so this will become new energy state is n square pi square h cut square 8 ml square, and next you have to put 4 particles. So when you will put 4 particles, so you will add and you will get 5 pi square h cut square upon 4 ml square, and then you put again the value of pi square h cut square ml square epsilon naught, and then you will get 5 upon 4 epsilon naught, and this is the required answer. So now the fourth sum, the ground state energy of 5 identical spin half particles which are subjected to 1D simple harmonic oscillator. So basically harmonic oscillator energy level is given by n plus half h cut omega. So this is the energy, how the state, but here n equal to 0 1 2 3. So this is the basic to solve this. Now there are ground state energy of 5 identical spin half particles. So again there are spin half, so filling will be done by 2s plus 1, 2 into half plus 1. So it will become only 2 particles can accommodate. So starting with n is equal to 0. Starting with equal to 0 here, because it is, remember, it is harmonic oscillator. Okay, so when you will put in, so what it means that if this is my simple harmonic oscillator, how can I draw? Let's draw it. N equal to 0, n equal to 1, n equal to 2. So 2 particles, how many are there? And there are, I think, 5. So this is the way you can, and n equal to 0, n equal to 0. So n equal to 0 means h cut omega by 2, and here when it will be 1, though it will become 3h omega by 2, and next it will become 5h omega by 2. So this is the way you will do this. So when you will add and you will become, you get the total energy, total ground state energy 13 by 2 h cut omega. So this is the final answer. So this is the final answer. So you can see the sum. You can pause the video and see what this sum means, question number 4, and you can do it by yourself also. So next question number 5, the lowest quantum mechanical energy of a particle confined in a 1D box of size L is 2 electron volt. The energy of the quantum mechanical ground state of 3 non-interacting spin half particle is. So again we have 1D box of size L with L, and the lowest quantum mechanical, it means the ground state energy is 2 eV. So the energy of the quantum mechanical ground state of 3 non-interacting spin half particles means. So what it means is, let's do it. What it means, see, we have 0 to L. So this is my n equal to 1, this is my n equal to 2. So only again 2s plus 1, so 2 into half plus 1, it it will become 2. So only 2 electrons can accommodate in one state. So I can do this and this. Okay, so this means n square, it means pi square h cut square upon 2m l square, which is given by 2 electron volt, and it is given. Okay, so now this will become 4 pi square h cut square by 2m l square, which means 4, and this is denoted by, I think, epsilon naught, or, and you can, whatever you can want to donate, you can donate 4 into 1. So it will become 2 epsilon naught, or 2 in first energy level is given by 2 electron volt plus 4 into 2. Okay, so what is this 2? See, basically this 2 is the that your number of electrons. Okay, this is the energy state 4. The actually, see, I can explain you a bit another way. See, basically 2 is the ground state, it is given. Okay, so number of electrons is 2, and the ground state energy we multiply is by 2, then next plus. So here is only one particle. Okay, 1 into what it is, the that is your 4, actually 4, and I should multiply here by epsilon naught, because here because here that pi square h cut square upon 2 ml square is equal to 2 electron volt. It is 2 electron volt, so I should multiply here by 4 into 2. So 2 into 2, 4, plus 4 into 2, 8, and this will become 12. So there is 12 electron volt. Okay, so what the hidden thing in this question is that pi square h cut square 2 ml square is equal to 2 electron volt, which is given. So you can take a look. Okay, so now we will move to our question number 6. Okay, so find the number of energy states and the energy levels in the range E is less than 15 h cut square upon 8 m square of a cubical box of side A. So now it is a cubical box. Okay, so you have to remember what is a cubical box. So we have studied about a particle in a box. This is in one dimension. So we have studied particle in a box which is in one dimension. Now cubical box is the version when we study this in your 3 dimensions. Okay, so cubical box of side A. What first I should make clear what I mean by cubical box and what is rectangular box and stuff like this. So first I'll talk about a rectangular box. Box. So here psi will be given as nx, ny, and z. Remember this in 3D. Okay, so it is given as x, y, z equal to under root 8 abc sine nx pi x by a sine ny pi y by b sine nz pi z by c. Okay, and energy level is given by h cut square pi square, I should write it properly, h cut square pi square upon 2m and here it is nx square by a square plus ny square by b square plus nz square by c square. This is a rectangular box, this is the wave function, this is energy. Same as cubical box, it is 3D. So here a equal to b equal to c is equal to, let L, because it is cubical, so we have same length, okay. So I should draw it properly. So so here a equal to b equal to c equal to L. So the above formula will become psi equal to under root 8 upon L cube, okay. Sine nx by L sine ny pi y by L and sine nz by z upon L, and the energy level will become h cut square pi square upon 2 L square nx square plus ny square plus nz square. So this is your cubical box, this is your rectangular box. So this is cubical box and this is rectangular box. So so this is the basic requirement of this question. Now we have to understand the question. Find the number of the eigenstates and the energy levels in the range which is less than 15 h cut square upon 8 m square. So how we will know that which states have energy less than 15 h cut square upon 8 m square? So let's do it. Okay, so here we have nx, ny, nz, three quantum numbers. So let's start with ground state 1 1 1. So their degeneracy is only 1. So always see, basically there are some cases in which ground state can be degenerate, but at this level you can take it as simple that the examples we will study here, that your degeneracy ground state will not will be not it will be non degenerate. It do not have any degeneracy. That means, what is mean by degeneration, what is mean by non degenerate states? Non degenerate state means the respective eigenstate, and this eigenstate has respective eigenvalue, that one eigenstate and one corresponding eigenvalue. But when the many states, many wave functions have one eigenvalue, this one corresponding eigenvalue, then they are called degenerate states, and the levels are called degenerate levels, and it is defined as degeneracy. Okay, so now if I put here 3 like the 1 plus 1 plus 1 in this formula, that I'll put this in this formula, when I'll put, so I'll get 3. Okay, when I'll put 1, nx is equal to 1, ny is equal to, here when I'll put here when I'll put nx is equal to 1 and y equal to again 1 and z equal to like it should be 2. Okay, so it will become the energy state will become, you can put here 1 plus 1 plus 2, so it's square, so it will become your what it will become, we can see 4 plus 1 5, 5 plus 1 6, so it will become 6 pi square h cut square upon 2 ml square. Okay, so you can do this. I think it will become square 2 2 4 6, yeah, right. Okay, so this is the case. It means it can be broken into 3 degenerate states. It means 3 eigenstates have the same value of energy, same value of energy. What I mean to say, I can do it in, here is the space, yeah, I can do it here is the space. So what I can do, that like n equal to 1. Okay, so n equal to 1, it is non-degenerate. There are 3 states which have same value, n equal to 2. Means A equal to 1, E1. Okay, so E1 is equal to pi square h cut square upon ml square ml square. So here will come 1 plus 1 plus 1, it will become 3 pi square h cut square upon 2 ml square. And what I mean by this, 1 1 2 state, 1 2 1 state, 2 1 1 state. Okay, so they will have same energy eigenvalue. It means E2 is equal to, it should not be denoted by 2, but for the reference I am denoting it pi square h cut square upon 2 ml square 1 1 square plus 1 square plus 2 square, which means 6 pi square h cut square upon 2 ml square. So it is 2 ml square. So this is the meaning of this. So I have to tell now that which energy state is less than 15 h cut square upon 8 ma square. So when you will do this, so you will know that number of energy eigenstates here will be 17 and number of energy levels is 6. Okay, so find the number of energy states are, so there are, answer is 17. So you have to calculate up to when you aren't sure that you have less than this value. So when energy level is less than this, will become the above this, so you have to stop there. You have to stop there, and then you will count the states. And you will get the number of energy states. So you can count here 1 2 3 4 5 6 7 8 9 10 11 12 13 14. I think 14 up to here it is. Energy levels are 1 2 3 4 5 6, yeah, 6. So energy levels are 6. So you can do this. Okay, so you have to count this. See, this you have to check it manually. There is no shortcut. You have to check it manually, but after some experience you can take a shortcut, but this depends only on your practice and experience level. When you are at this initial stage, you have to calculate bit by bit and with your hand. Okay, so there is no shortcut of this. Only it means that when energy will be greater than 15 h cut square upon 8 ma square by this method, you have to stop. Only the energy less than 15 h cut square upon 8 ma square will be the number of energy states, so it will be 17. Okay, so you can check it. I can make you sure this. Like if you put E equal to pi square h cut square upon 2 ml square 1 square plus 3 square plus 2 square. So you will get 4 plus 9 plus 1 10. Okay, so you will get 10. No, sorry, my mistake. You will get 9 plus 4 13 plus 1 14. Okay, now you will get, so you will get square h cut square upon 2 ml square 1 plus 9 plus 4. So you'll get 14 pi square h cut square upon 2 ml square. So it is so you can check, it will become 2 ml square. Okay, so number of energy states are 17 and number of energy levels is equal to 6. So now next question, the energy of a single particle in an infinite potential box is E naught n square, where E naught is equal to h cut square pi square upon 2ma square n equal to 1, 2, 3 up to so on, if 3 non-interacting bosons. So now we have bosons. I have told you that bosons have no such restriction. Bosons have no such restriction as Pauli exclusion principle. So it is very simple. So you have to put 3 bosons in your particle in a box. Okay, so it means you can put it in n is equal to 1 state, and you will multiply it by 3, and your state is pi square h cut square upon 2m three into pi square h cut square upon 2m a square. Okay, so you will get the answer 3 epsilon naught. Okay, now 8 sum. Considering a system of 8 non-interacting identical quantum particles of spin 3 by 2 in 1D box of length L, the minimum excitation energy of the system in units of pi square h cut square upon 2 ml square. So now you have to calculate excitation energy. So you have to calculate now excitation energy. So the filling is done by 2s plus 1. So we can only so now you can see the application of formula 2s plus 1. So 2 into 3 by 2 plus 1, it will become 4. So now in one state 4 particles can come. So in one state 4 particles can come. Okay, so now the question is where is the question? Oh. So the question is the minimum excitation energy. So excitation energy is calculated, is the difference between the your ground state and between the two respective states. Actually it is the you have to excitation energy is the excited state energy minus ground state energy. So it's actually the difference. So you have to calculate the respective two states. So to calculate the respective, so when we'll calculate the ground state, let's calculate the ground state. So ground state energy, I've showed that 4 particles can come, and next in also 4 can come, so you have accommodated in 8, total 8 in 2 states. Now in excited state, obviously one particle will jump to higher state, so it will become if we go to n is equal to 3, it will so it will become n equal to 3, n equal to 2, n equal to 1. Okay, so that you will calculate the ground state and excited state, and you will, this is the ground state, 20 pi square h cut square upon 2 m square. Similarly, you will calculate excited state, 4 into E1, 2 into 4 into E1, 3 into E2, and 1 into E3. So you will calculate and you will get 25, and you will minus them, then you will get 5 pi square h cut square upon 2 m square, and this is your excitation energy, and this is your excitation energy. Okay, so now we'll come to our next question. A 2D square rigid box of side L contains 6 non-interacting electrons at T is equal to 0 Kelvin. The mass of electron is m. The ground state energy of the system of electron in units of pi square h cut square upon 2 ml square. So now it is 2D. So now it is 2D box. Okay. So we have studied 3D. We have studied 1D. We have studied 3D. Automatically 2D is n square plus ny square. Okay, nothing in this to tell. We have studied 1D, 3D, so automatically 2D will be n square plus ny square. Okay, so here you have to see this side L is same. It is not rectangular, it is cubic. I cannot say cubical because it is 3-sided, it is 2-sided figure, but here A equal, but here L. Okay, so when E1 will be there, pi square h cut square upon 2 ml square, a 2D square rigid box. So there are 6 non-interacting electrons. So 6 non-interacting electrons. So you have to put them. So there is 2D box. So I told you that the ground state energy will be non-degenerate. It will not be degenerate. So how can you put the question is how you can put now these 6 non-interacting particles. Okay, so now what we will do, first we will apply the formula. E is equal to pi square h cut square upon 2 ml square nx square plus ny square for 2D. This is for 2D. Okay, now E1, first we have to calculate the ground state. Okay, so ground state will have only that 1 n is equal to 1 and n is equal y is 1. So we will get 2 pi square h cut square upon 2 ml square. Now E12 or E21, because I told you that the ground state will be E1 and so 2 of states, that is 1 comma 2 and this is 2 comma 1. This will have the same state. Okay, so I have shown here also. So 2 into 2 pi square h cut square point 2 ml square, and again we will add plus 4 into 5 pi square h squared square by 2ml square. So your 6 particles will accommodate like this. Two, two, two. See what I have done. The formula is still 2s plus 1. 2 into 1 by 2 plus 1. So it is 2. But here it is 2D box. So second state, that is E2, will be degenerate. It is non-degenerate. It is degenerate. So it can accommodate now. So 2 particles is at most accommodate, but there are 2 states now which have same eigenvalue, that is E2. That's why there are now 4 particles. Okay. So but this formula still remains the same. There is no contradiction to this formula 2s plus 1. It is still the same, but the question is it is now 2D box. Now it is not 1D box. So you have to remember this. Now what we will do, this question I think we have done with it. Now question number 10. So a quantum mechanical system consists of 1D infinite box as indicated in the figure below. So there are 3 identical non-interacting spin half particles in the box, and the ground state energy of the system is found to be E0 is equal to 18 electron volt. If 7 such particles are placed in the box, what will be the ground state energy in units of EV? So now 3 particles of spin half in the ground state and which have energy 18 electron volt. If 7 such particles are placed in the box, what will be the ground state energy in units of EV? So now you have to tell about 7. 3 it has given of 18 electron volt. Now you have to calculate of 7 such particles. Yeah. So if I have to place 3 particles, what I can do, two into half plus 1 is equal to 2. So at most 2 electrons can accommodate. So it has given this ground state, the energy of the ground state energy of the system is found to be 18 electron volt. So total it is given by 18, so you need not to calculate. So what you have to calculate from this, that what is the value of pi square h cut square by 2m square. Ultimately we have to put this in when we will do for 7. So ultimately pi square h cut square upon 2m square is equal to 3 electron volt, which is the ground state. So this is the ground state energy. Okay, so now you will put 7. So now this pi square h cut by pi square h this pi square h cut square upon 2m square equal to what? It is 3 electron volt. It is 3 electron volt. Okay, so it is 3 electron volt. Okay, so I have take common, so you can calculate 2 plus 8 plus 18 plus 16 is 132 electron volt. It is 132 electron volt. Okay, so I think there is no need to put it 3 if it is asked in the question that do it with when you will given the value that pi square h cut upon 2m square is equal to 3, then you can do this. Otherwise I don't think so. There is need to put it 3. You can keep it as it is, that is pi square h cut square upon 2m square. Okay, so yeah, I don't think so there is any, yeah, you can do it like this. So there is no need to put this. Okay, so there is no need to put. Now question number 11th. What is the ground state energy of 6 non-interacting electrons in 2D isotropic simple harmonic oscillator? So the concept is of 2D isotropic. Okay, so we know that En is equal to N plus one D. Okay, so for 2D, what is the formula? Nx plus Ny plus half h cut omega, which will become Nx plus Ny plus 1 h cut omega. Okay, so this is for 2D. Okay, so I told that this is non-degenerate. It is non-degenerate. And this is degenerate. So automatically first it will become can accommodate only 2s plus 1 by the rule, and again this 2 in E is equal to 2 state. So you calculate with this formula Nx plus Ny plus Z, so you will get 10 h cut omega. Okay, so this formula you have to put. Okay, so now the last question. 3 fermions of spin 3 by 2 is registered in 1D harmonic oscillator frequency omega. What is the energy of the ground state configuration? So now there is spin 3 by 2, so 2s plus 1 by the rule, so you can accommodate 4. So there are 3, so they will take the first state. So it can accommodate, this state can accommodate 4, but we have to put 3, so you can multiply by 3 into h cut omega by 2. So you will get the answer. This is very easy. So this is your final answer. So I think the video is too long. I should stop here now. So I've done all the numericals, all the problems that have come past in your gate, jest, net, TIFR. All the problems have been solved in this exercise. So this exercise is very important. I solved all the problems. I don't think now any problem is left, but I think I have not covered the last year net and the last to last year also. So I think rest I have all covered the questions of gate, net, jest. So I can write here. So gate, net, so all questions are covered. Okay, all covered. Okay, so thank you. So I think this video is up to here only, and it is too long, so I should stop here now. Thank you very much.